In the 4 years I've spent studying biology and chemistry, I've been enamored with the complex mechanisms that give rise to life, from oxidation and reduction reactions to the development of embryos. I've learned the language of chemistry and have been able to solve the puzzles of reactions on paper, but something was distressing me. Despite having all of this theoretical knowledge, I felt worlds away from the grand discoveries made by scientists before me, and the biopharmaceutical inventions being produced en masse to treat our modern ailments. I wanted desperately to bridge the gap between what I was learning in the classroom and the process of physically creating biological products like vaccines, insulin, and gene therapies. I wondered how we acquired such tiny molecular ingredients and combined them in a way that was safe and purified, ready to be sold by pharmacies in bulk. I knew how proteins worked. I could identify their structures from primary to quaternary, but I did not understand how one could ever attempt to isolate them. My curiosity led me to one specific technique, one so powerful that it has been referenced in over 736,000 studies since 1941, and has given rise to many of the life-saving modern pharmaceuticals we have access to today. In this video, I'm going to be talking about column chromatography. There are many derivatives of this technique that I'll delve into later in this video, but they all function in the same key ways, with the objective of physically separating components of a mixture. In column chromatography, a column is packed with a solid material called the stationary phase. The mixture you want to separate is then poured on top of the column. Finally, a liquid mobile phase is run through the column. Molecules will differentially interact with the stationary phase depending on their properties. Those that stick more strongly will take longer to flow to the bottom and out of the column. As they come out, or elute, at different times, they can be collected separately, and you will have successfully isolated your target components. This technique of column chromatography meaning to show with color, was first developed by a Russian botanist named Mikhail Tsvet, whose last name ironically also means color. In 1901, Tsvet wanted to separate plant pigments, so he packed a column with calcium carbonate as a stationary phase, poured his plant extract at the top, then eluted its components with an organic mobile phase. The plant pigments separated into distinct colored bands, including chlorophyll and his newly discovered carotenoid pigment. He didn't know it then, but his methods, which didn't catch on until much later in the century, would evolve into 4 incredibly powerful derivations that could separate molecules based on size, charge, affinity to specific ligands, and surface hydrophobicity.